Hello and welcome to our last section on air pollution. We're going to talk a little bit about effects and remediation in a little bit more detail, focusing on acid rain, weather and pollution, and pollution controls at the very end. Acid rain in general affects a lot of the U.S. and particularly the industrialized Northeast. If we look at the pH of the rain in this area, as opposed to the pH of the the Midwest instead of the East, in the far west, we see pH ranges in some places as low as 4.4. The cause of this is the input of SOx and NOx, sulfur dioxide, nitrogen oxide, into the atmosphere. It mixes with oxygen and water in the atmosphere to create nitric acid and sulfuric acid, both able to dissociate a lot of hydrogen ions. And this can have a lot of negative effects, especially in the northeastern U.S. and Canada. We see where there's lots of rainfall, we see it will essentially kills vegetation, and it is toxic in waterways for certain kinds of fish, which can't tolerate pHs in the range of 4, to be sure, and so we see streams losing ecosystems as well. Another thing that we get from air pollution is air pollution related to weather. Now, we wouldn't necessarily think that polluting the air would cause weather, but it turns out that things like cloud formation require what we call condensation nuclei. These are particles in the atmosphere that will allow for water to condense on them. And so one thing that we do by cleaning the air is remove condensation nuclei. This means that snow and rain might be different in different areas, especially more common in places where you have more pollution. Clouds also may be more common in those areas as well. Putting in hot particulate, as you see in these images here, from industrialized areas into the atmosphere, can create what's called a temperature inversion layer. And what that does is it puts hot material high up into the atmosphere. Now, the atmospheric temperature tends to decrease as you go up. This is what we call the sort of the ambient air temperature, if you will. Heat radiated from the surface of the Earth decreases as you move up. Putting hot material up here creates a warm layer. Now the warm layer is already happy to be high up because it's more buoyant, and so it will just sit up here, and it works to sort of cap any other materials that are rising up from this area. So we see what's called the temperature inversion. Temperature decreases with altitude in this first diagram. Here we see it decrease, then it increases, and then it decreases. And so instead of allowing the material to rise and sort of dissipate and be mixed into the atmosphere as part of the variable components of the atmosphere, soot, NOx, SOx, and so on, O3 that get created, all that stuff gets carried up and hangs out as a kind of cap. Okay? So a couple ways that we can see weather or pollution and weather being connected. LA was notorious for smog, and it has both a combination of this photogenic, not photogenic, UV light created fog, right? So smog, I should say, created by UV light coming in, interacting with all the nitrogen oxides and volatile organic compounds put into the atmosphere. But what you also see are the San Gabriel Mountains, and so we're in LA basin here. We're looking back towards the mountains. So these mountains here, okay, are these mountains here, the San Gabriel Mountains. And during the day, as the Earth's crust heats up, you get a strong onshore breeze from the ocean, which will push all of that smog back up against these mountains and just hold it in place. So it's both a combination of local or regional weather effects and then also the amount of pollution in the atmosphere. Right? How do we control some of these things, elements of pollution? in the 70s, we passed the Clean Air Act, and that really cut back on the amount of pollution created by coal-fired power plants. Over half of our electricity, probably a third of our electricity is still generated in the U.S. by coal-fired power plants, but they've gotten cleaner actually over the years. You will sometimes hear people talk about clean coal. There's really no such thing as clean coal because in the end, this coal is still producing CO2 and CO, neither of which are efficiently scrubbed from the atmosphere in a cost-effective way. I know it is possible to scrub CO2 from gases and to remove it, right? But to do it for massive power plants on an industrial scale is probably economically something that's not really feasible. Another way that we have worked to improve or reduce air pollution, okay, is to improve the standards on cars. Now, we haven't done a very good job of it. I did show you that emissions are down, but in 1979, the standards were cars were 19 miles per gallon and 17.2 miles per gallon per light trucks. The actual mileage, though, was quite a bit less, looking at 14.6 and 11.6 miles per gallon. So while standards were set, the mean standard of driving around town or whatever your average wasn't really being achieved. In 2008, we see cars at 22.5 and light trucks on average 18.1. So there is improvement, and I've already showed you a graph that shows that. But there's a big improvement, right? Not vast improvement. So reducing emissions, legislating emissions, that's been useful. Legislating clean air, requiring coal-fired power plants to scrub their air. Carbon offsets are another mechanism by which we can reduce the amount of, for instance, CO2 that's being put into the atmosphere. But as far as we know, as far as I know, there are no sulfur dioxide offsets. Okay, so people can trade on carbon all they want. Although I have to say that it is a somewhat nefarious business in itself. Another possibility, and this is really a group of possibilities that are under this umbrella, is carbon sequestration. Reforestation is a possibility. Okay? Obviously, plant growth is the best solution to fixing CO2, getting it out of the atmosphere and getting it back into a reservoir where it doesn't really work as a greenhouse gas. Ocean injection has been brought up, and deep ground injection. Reforestation is probably the least troublesome of all of these, which is simply, putting back the plants that we lost in the past. If you take a look at the U.S., here you can see areas where we see mosaic restoration and wide-scale restoration opportunities. Where are most of those? Well, in the industrialized east and northeast. We also see parts of South America and Africa and Asia as places where mosaic and widespread reforestation are possible. Okay. And this can represent a number of different activities, from repairing and fixing the soil so forest can come back, to just weeding and maintaining a region. Okay. In terms of emission controls and reducing the amount of emissions, this is just an example of a coal-fired power plant scrubber. It's a little out of order here, but the idea is that gas to be scrubbed comes out of the plant. So this would be the exhaust gas. Comes into this chamber. The chamber has like a lime mixture which is sprayed on it, a calcium-based solution, calcium carbonate-based solution, and that will react with those NOx and SOx and keep them in this chamber, and then what leaves is something that's been cleaned up. Okay. The last carbon sequestration example I want to talk about a little bit has to do with injection into the subsurface. One of the things that we already do for it's not widespread, but we already do for things like wastewater or toxic materials is inject them into what are really deep reservoirs. So a deep reservoir is below the groundwater table, presumably, and not connected. And it is probably around 7 to 9 kilometers below the Earth's surface, okay? Maybe deeper. And we would inject it into a saline aquifer, which wouldn't be useful for drinking. Another option for CO2 sequestration is to pump it into an existing coal or oil bed, or oil shale, as a way of pressurizing the system in what's called enhanced oil recovery. Most oil or hydrocarbon systems only produce about 1/3 on their own, 1/3 of their capacity. So CO2 is commonly used, but to stuff back into the system and pressurize it. Several problems exist with this. One is leakage, right? We don't know if it's fully sealed up and where we might find leakage in the future. So that's a definite problem. Although we'll never probably need to drink this particular water. Another possibility is to inject it into a salt cavern or a salty impermeable layer in the subsurface as well. Again, we're just sort of reorganizing where we put this material, and it always has that potential to be released in the future. Some of the issues here, you can obviously see one of the feedback loops that's involved. If we're using oil as or CO2 as a means to extract oil, we're just feeding this process of creating more CO2. Now, some companies like Statoil in Norway are already operating CO2 sequestration injection systems, but they're doing this to avoid paying taxes, right? So it is about the money that really drives this process. It is an active area of research in the geosciences, but I will say that there is no significant CO2 reduction occurring from any of these techniques. They're primarily in the experimental, the research, or the preliminary stages with regard to being widespread. Clearly, there are some minor examples that are up and operational. Okay? All right, so that kind of wraps up a summary of air pollution, ways that we can deal with or remediate air pollution. Obviously, legislation makes the most sense and has been effective in the case of O3. I will say that O3 and the ozone depletion was a special case. In fact, the companies that produced those chlorofluorocarbons were able to replace them with some other chemical. So there was a direct substitute that was available, and that made the entire process of limiting CFC production and usage much easier. If there had not been clear replacement chemicals available, it is likely that I think the U.S. would not have gotten involved in the Montreal Protocol in the way that we did, and I think it would have been less effective for that reason.